Hi everyone, good afternoon. So today we would be discussing what regular expression and like expression does, how we can search through them. Also we'll study what schemas are. So let's start with schemas. So schemas, as a definition says, schema is basically how data is organized in a database. This is basically how we arrange various tables, various attributes, various entities in a database. So schema gives us understanding of various relationship between the tables, what is the how various entities are connected, what are the keys in particular tables, and it also helps to understand how we can arrange the data in a database. So schemas can be classified into number of types. We have a conceptual schema, we have a logical schema, we also have a physical schema. We'll have a look at it. So we'll have a look at it now. The conceptual schema basically is a kind of a blueprint. So it's like a background, what we set up for a particular kind of a data or a particular kind of a business solution or a sales activity that we are or a kind of a startup or a kind of a business that we are starting. We set up a concept for it. So a conceptual schema is basically a broader picture. It helps us understand what are the various like before we set up a business, we need to understand what departments we need to have, whether it should have an IT department, whether it should have an HR department, whether we are starting a product based business or a service industry, or we are entering a service industry, or we need what kind of information do we look forward for logistics. So all these things become the part of a conceptual schema where we are just discussing how various data points would be gathered, what are the various data points from which the information would be gathered. Now when it comes to logical schema is the next step to the conceptual schema, where we describe various tables, their columns, their entities, what are the attributes, how various foreign keys and primary keys and various entity and referential constraints come into picture. So logical schema is kind of where we put in various logics into our database, into our tables. We decide what tables need to be used, how these tables are linked together, how these tables would behave with each other, how to access one table from another table. So that becomes the part of a logical schema. Physical database schema is basically, it provides us the technical information that we gather from logical database schema. So it's like we put everything into action what we have obtained from the logical schema and the conceptual schema, such as it includes table names, fields, entity relationships, etc. That is, it also includes the syntax that we would use to create these structures, create the tables. So when we get into action in creating the tables, defining the constraints and everything, that becomes the part of a physical data schema. So let's now get into what is a star schema and what is a snowflake schema. Star schema and snowflake schema are basically the extensions of a physical database schema. So there are two schemas basically. One is a star schema, another is a snowflake schema. A star schema, both these kind of schemas includes a fact table and a dimension table. In a star schema, we only have a fact table, one single fact table, which is connected to the other dimensions. There is no other sub dimensions to these dimension tables. Whereas in a snowflake schema, the dimension tables which are connected to the fact table have other dimensions attached to it. So there, let's take an example. So over here, what we are seeing is a star schema where we have a fact table which is connected to the multiple dimension tables, but there is no connection between the dimension tables. One fact table is linked to one dimension table and one dimension table is linked to one fact table. There are no sub dimension tables. This forms a star-like structure, so that's why we call it a star schema. We take an example over here. Let's say this is a fact table which we have a revenue. We have various IDs over here. So fact is something where we have factual information. Let's say a number 10 is a fact. But when I say age is 10, so age becomes a dimension of that fact. It gives a definition to that fact. So over here we have different dimension table. Let's say dealer, date dimension, branch dimension, and the product dimension. So all these tables are linked through various foreign keys, like dealer ID in fact table is a primary key, and a dealer ID in the dealer table is a primary key, but the dealer ID in the fact table acts as a foreign key through which we can access the information from the dealer table. That's how a schema, a star schema looks like. It forms a star kind of structure. It's a simple schema where we don't have a larger database. It generally works out good for a smaller databases where the information is less and we can use fewer joins and can manage the database easily. Whereas on the other hand, when we look at a broader picture, when we have enhanced data, when we have more amount of data, we get into Snowflake schema. So now let's understand what a Snowflake schema looks like. So this is the same extension of the star schema. We have the gray tables you can see that form the part of the star schema. But when these dimensions, the dimension tables of the star schema had sub-dimension tables, like, so it is the same like the star schema I showed you. So the same I have over here. So when these dimensions have sub dimensions, like for dealer we have location, we have country, for product we have variant kind of table, we have a sub dimension table which is a variant table. So that makes it a Snowflake schema. When we have data which is expanding, where data is generally, it is continuously expanding, you can't put a stop on the data. So Snowflake schema is something that is used on regular basis in the industry. The major difference when it comes out between the Snowflake and the star schema is Snowflake schema. In a Snowflake schema, the dimension tables have sub-dimension tables which are in turn related to or connected to the fact table. Whereas in a star schema, there are only dimension tables which are connected to the fact table. There are no sub-dimension tables. These dimension tables are only connected to the fact table. Whereas in a Snowflake schema, the dimension tables have more tables which are attached to it, which are called the sub-dimension tables. So that's the major difference when it comes between star and the Snowflake schema. We'll see what differences come up. So let's say I have to reach out to a location ID. So I traverse through fact table, we move to the dealer table, then we move to the location table. So we put a number of joins. There are multiple joins involved in it. We can take another example over here. Let's say there's a sales fact table which is connected to various dimension tables. So the dimension table is connected to a supply dimension table which gives us the supply information. Location table is connected to a city dimension table that gives us the city information. So the super key, the supplier key, helps us getting information from the supplier table, which is a foreign key in the dimension item dimension table, but a primary key in a supplier dimension table. So that's how we can access the information from a Snowflake schema. Here's a brief description of showing the difference between star and the Snowflake schema. So star has only dimension tables, Snowflake schema has sub-dimension tables. Now, what's the difference between the two models? So as we read, a Snowflake design can be slightly more different in terms of database space. This is especially true if the dimensions have many large text fields. However, in general, the size of fact tables outweigh the size of the dimension, but by a large enough factor. So what do we mean? So Snowflake schema, you might think that Snowflake schema is too big and it would require more space as compared to a star schema, but genuinely Snowflake schema is a space optimized database schema. It has optimized the data in such a manner that let's say so over here the location ID. So it is something, I'm not filling up the location and the country information in the dealer table itself. I have two separate tables, so my dealer table is not loaded, which is reducing the burden and also reducing the query processing time. So if I need to search location and country, and if these are present in the dealer table itself, the location and the country information, then every row in my dealer table will be searched row by row. Every row would be searched. That would take more time to process a query. But now as I have two separate tables, so the load on my database, load on my dealer table has reduced immensely. I can use only few rows would be searched in the location table based on the locator ID, and it will find me the location, the city, the region, whatever it is. I'll get the information instantly. But if this location information would have been in the dealer table, that would have increased the size of my dealer table, that would have put more load on my database, and search time for a location would have also increased. Similarly, when I have multiple tables, yes, there would be multiple joins, and yes, joins make the task easier. It optimizes the data very nicely and helps to reach out to various information in a very faster and an easier process. That is why a Snowflake schema is space optimized and a efficiency wise a good schema to work on to. So let's go to another point. Star schema simplicity has advantage of requiring fewer joins to build and maintain the database. However, there are instances that will call for a Snowflake design. Definitely, as the data is increasing day by day. So we read over here saying that star schema, however, requires the need of a Snowflake design. Why? Because data is increasing gradually, and on the time basis, data would be millions and lakhs and trillions of data would be there. So, Snowflake design is something that can handle a larger set of data. Whereas a star schema, I agree, there would be lesser joins, there would be lesser maintenance of the database, but it has a lot of restrictions. It cannot handle large amount of data. It will fail at some point of time. The time to reach out and extract information from a star schema is more as compared to a Snowflake schema. Coming up to the next difference, some OLAP reporting tools work more efficiently with the Snowflake design. So yes, whether it is OLAP or OLTP, like we discussed, Snowflake schema gives us a flexibility, gives us a better understanding of how designs are made, how we can reach out, how fast we can access the data. So whether it is OLAP or OLTP, Snowflake design is the need of the hour, and that's why every industry, every workbench, every database uses a Snowflake design schema only. When it comes to the multiple tier joins available in a Snowflake design can make aggregation simple as well. Obviously, joins make our life easier, and yes, aggregations become quite easier when we use a Snowflake schema.